Okay, so this is part 2 of section 4.4. So we left off with this story problem dealing with cans, aka cylinders, and let's get right to it. So a rectangular sheet of a perimeter 48 inches and dimensions are x inches by y inches is to be rolled up into a cylinder. So we have a rectangular sheet and they give us the perimeter. So the perimeter is 48 inches. And then they tell us that the dimensions are x inches by y inches. And we're rolling it into a cylinder. What value of x and y gives the largest possible volume? So what this means is that we are maximizing volume. So the first thing that we're going to do, we're going to figure out the equation of the thing that we are optimizing or maximizing in this case, and that's going to be volume. So we know that volume for all shapes, it's always going to be the area of the base times the height of the object. In this case, it's going to end up being a cylinder. So a cylinder, okay, remember you're starting off with a rectangle, and the dimensions are going to be x by y, and then we are rolling it into a cylinder. So that means this height right here is going to be, you know what, let me just for my purposes, I want height to be y and left and right to be x. Just makes more sense because that's how it is on a coordinate plane. So when you fold this up, then this guy right here is going to end up being your y. And now your x is a circle, right? So this top portion ends up being a circle. So x ends up being equal to 2 pi r, which is the circumference of a circle. Okay, so let's keep that in mind, because here we have to come back to this. So volume of all shapes is always going to be big B, or the area of the base, times the height. In this case, our base is a circle. So the area of a circle is pi r squared, and then our height is y, just based on our picture. Okay? So you notice here that you have two variables, r and y, but we'll come back to that in a second. So the next step is this equation that is actually given to us. They tell us that the perimeter is equal to 48. And we know that the perimeter of a rectangle is going to be, 48 is going to be equal to 2x plus 2y. So this is the equation of a perimeter. And the reason why this is important to use is because we have two separate variables here. So one of these variables has to become the other. Okay? So basically, I'm gonna solve for y in this case. And the reason why is because of this, which we'll come back to that in 1 second. So I'm going to solve for y. So you take your 48 minus 2x equals 2y, right? And then you divide everything by 2. So you end up with 24 minus x equals y. Correct? So now we have our 24 minus x equals y. So over here, I now have pi r squared, and instead of y, I can write 24 minus x. I still have technically two variables, but what do we know about the relationship between x and r? We know that x becomes a circle, so x actually is the same thing as 2 pi r. So actually I can rewrite this guy to be in terms of x. So what I mean is I can basically maneuver this guy around, so x divided by 2 pi equals r. Okay. Or, actually what would be so much easier is if I rewrote that x as 2 pi r, just to not have to worry about fractions. Okay? But either way, you can either rewrite this as x over 2 pi, so you can have them all in terms of x, or you can rewrite this guy as 24 minus, what is x? X is 2 pi r. So now this is my volume equation. Okay, when we clean this up, our volume equation ends up being V equals, let's distribute, so that's 24 pi r, oh, I don't know why I just did that, pi r squared, minus this times this, which is 2 pi squared r cubed. Now please recall that this right here is just the number, and this whole entire thing is just a number. So now when we start taking the derivative, so let's graph it, let's solve it analytically, algebraically. So after we've gotten our maximizing equation in terms of one variable, the remaining is to get the derivative. So v prime is going to be, I don't know why I forgot the 24 here, sorry. So that 2 comes down, so that becomes 48 pi r minus that 3 comes down, so that's going to be 6 pi squared r squared. And now I'm going to set this guy equal to 0. Okay, next up, let's see if we can solve this without a calculator, which we can.
I'm having trouble connecting to the internet. Take a look at the help section in your
Alexa. Alright, so let's take out GCF. So we got 6 pi r is a GCF between the 2's, and we're left with 8 minus 1 pi and 1 r. So you solve with the zero product property, and you end up with r equals 0 here, which cannot happen. You can't have a radius of 0, right? If you have a radius of 0, then you have no cylinder. So this can't happen. And here, you set this guy equal to 0, and once you solve it, so subtract 8, divide by negative pi, you get r equals 8 over pi. So now we know what our r is. And just to do a quick check, okay, that's our critical point. And I want to see what happens if I plugged in a number before 8 over pi into this derivative and after 8 over pi. So before 8 over pi, you can pick a number 1. It doesn't really matter, and that's going to go in for r. So if you pick 1, you're going to get 48 pi minus 6 pi squared. Once you do the math, you end up with a positive. And then after this guy, 8 over pi, let's pick 10. You plug that in, and you get a negative. So you notice that the slope is going up and then it's going down, so this is obviously a max, so we're good to go. That this is our max. Now this is our maximizing r. But the question asks what values of x and y give the largest possible volume. So can I figure out, if I know that r is 8 over pi, can I use that to see what is x and what is y? Yeah. Do I have an equation that compares x and r? I do. I already know that x equals 2 pi r. So basically x is going to be 2 pi times 8 over pi. So the pi's cancel out, so x is 16. And that is going to be in inches. And now that I know my x, I have an equation that solves for y. So y is 24 minus x. So y is 24 minus 16. So we get y equals 18 inches. So we found the values of x and y. That gives us the largest possible volume. So the largest possible volume, if it asked for that, would be whatever pi times 8 over pi squared times 18 is. Okay? Alright, next up is going to be inscribing figures. So it's not that bad, inscribing figures. So let's get to it. So a rectangle is to be inscribed under the arch of a curve, y equals 4 cosine of 0.5x. So this is our arch, and we are inscribing a rectangle from x equals negative pi to x equals pi. What are the dimensions of the rectangle with the largest area? And then it asks, what is the area? So obviously we are going to be maximizing area. Okay? And we're maximizing area of what shape? It's going to be the rectangle. So we are maximizing area of a rectangle, which is base times height. But before we can move on, we need to draw what this picture is saying. So I'm going to start here. I'm going to draw my x and my y. And first I'm going to draw my arch, which is y equals 4 times cosine of 0.5x. From negative pi, so I'm going to put negative pi here. You know what, let's just, because I have all the space, let's put negative pi here. This is going to be negative pi over 2. So negative pi over 2 is here. And then we got negative pi here. So at negative pi, if you plugged in 0.5 pi, which basically is pi, negative pi over 2, and cosine of pi over 2 is going to be 0. 0 times 4 is 0. And the same thing is going to happen at positive pi. It's going to be 0. Okay? When x is 0, so cosine of 0.5 times 0, which is, what is 0.5 times 0? It's 0. Cosine of 0 is going to be 1 times 4 ends up being 4. So 1, 2, 3, 4. Okay? And then a few other points at negative pi over 2. So if you have 4 cosine of 0.5 of negative pi over 2, you'll end up with 2 and 2. So here's our figure, our arch. Right? And the word inscribing just basically means what is the largest rectangle that I can draw underneath this arch. Okay? So the idea is I don't know what the x value is right here. And honestly, I know what the height is. The height is always going to be touching y, or the height, is always going to be touching that curve. So the height is going to be right on 4 cosine of 0.5 x, depending on what this x is, but I don't know what that x is. And because this figure is perfectly symmetrical on both sides, then it's also going to be the same distance x on this side. And this is the area of the rectangle that I am trying to figure out. Trying to figure out what is the biggest rectangle that I can place under that arch. Okay? So I just told you what the y is, which means that this guy right here is going to be our height. And it's going to be always the case when you're inscribing figures. Your height is going to be wherever it touches that curve. And then the base is this whole entire thing, which as of right now, all we know is that the base is equal to 2x's. I don't know anything else yet. So I have my height, I have my base. Now I can come over here and basically plug that in. So area equals 2x times 4 cosine of 0.5x. So if I just distribute that 2x or multiply everything out, I get area equals 8x cosine of 0.5x. Do I have only one variable in the equation? Yes, I do. So now I can just go ahead and figure out the derivative. And in this case, these are two things multiplied together, so we're going to use the product rule. Okay, so I'm going to need a little bit more space, so let's do the derivative right there. So I'll take the first guy as he is times the derivative of the second. And the derivative of the second is going to be the derivative of the outside, which is negative sine of 0.5x, times the derivative of the inside, which is 0.5. Okay, plus the second guy as he is, which is cosine of 0.5x, times the derivative of the first, which is 8. Okay, once all of this stuff is being multiplied together and all of this is being multiplied together, right? So when you just clean this up, it's basically going to be, let's multiply the numbers together. So 8 times a half is going to be 4, and there's a negative here, so that's negative 4 x sine of 0.5 x plus 8 cosine of 0.5 x. And then the next step is we set this up.
I'm having trouble connecting to the internet. Take a look at the help section in your Alexa app.
Set this equal to 0. Now I wish I had my calculator and I can show you how to do the numerical solve for this in your calculator. If you don't know, this is impossible to solve without a calculator. It's not impossible, but it's going to take too long. So if you don't know, please look up on YouTube numerical solve on TI Nspire. Nspire. It's going to be a life changer. So once you do that, you end up with x equals 1.721. That's going to be how big your x is. Okay, the length of the base from right here to right here. And the reason why this is helpful is it's able to, we are able to figure out what the dimensions of the rectangle are, and then at the end, what is the area. So if the x is this, then the base is going to be 2 times this, right? Because we said earlier that the base is 2x. So that ends up giving us a number you guys can do in the calculator. And then the height is going to be, what is our height equation? It's right there. So it's going to be 4 cosine of 0.5 times 1.721. You do that, you get your answer. And then the last thing is, what is the area? And the area is going to be this times this. So 2 times 1.721 times 4 cosine of 0.5 times 1.721. And that gives us 8.98 units squared. They don't give us the units, so we use the word units. So the biggest rectangle that can go underneath this curve has an area of 8.9, which means that the length from here to here is going to be 1.721, and from here to here it's going to be 1.721. Alright? Okay, so in class I gave you guys, I showed you these steps, which are a little bit more elaborate than the ones that were given in the notes earlier. So feel free to use these, write them down somewhere on the back of your sheets. But that is it for part 2, and we will complete the problems we were working on in class today in class tomorrow. Alright, good luck.